be possible. How we can compare the oxidation state with stability? So for that we have one small logical kind of thing. For example, I'm just going to take N chlorine for the example, for the sake of example. So it's having the atomic number of 17, is it right? So it's 1s2, 2s2, 2 plus 6, 3s2, 3 plus 6, 4s2, then it's 20, sorry, then it should be 5. Okay, it's done. So this is the, it is the electronic configuration for your chlorine. Okay, chlorine in an electronic configuration. Aishwarya, it's visible. I can see in my desktop. If you having any network issues, so please log out and log in. It's visible. So okay, so now the valence electron, I'll do one thing, I'll just write the outermost electronic configuration. It's have 5, right? 1, 2, 3, 1, 2. So 5. 1 is unpaired electron. Okay, so here I'm saying if the unpaired electron number, if you are balance it out, you might have balance in the two ways. Either you can add or you can remove that. ನೀವು ಅನ್ಪೇರ್ ಇರುವಂತಹ ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನ ರಿಮೂವ್ ಮಾಡಬಹುದು, ಅದರಿಂದ ಕೂಡ ಸ್ಟೇಬಲ್ ಆಗುತ್ತೆ. ಅದರ್ವೈಸ್ ಜಸ್ಟ್ ಆಡ್ ದ ಎಕ್ಸ್ಟ್ರಾ ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ ಟು ದಟ್ ಟು ಬಿಕಮ್ ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್. ಸೊ ಅನ್ಪೇರ್ ಇರುವಂತಹ ಎಲೆಕ್ಟ್ರಾನ್ ನ ರಿಮೂವ್ ಮಾಡೋದ್ರ ಮುಖಾಂತರ ಸ್ಟೇಬಲ್ ಮಾಡಬಹುದು. ಅಥವಾ ಈಗ ಅನ್ಪೇರ್ಡ್ ಒಂದಿದೆ, ಸೊ ಯು ನೀಡ್ ಒನ್ ಮೋರ್ to balance it out or to make and paired. So you are bringing one electron and you're making a pair. So that's also give the stability. Are you able to understand? So in these two terms, we can make the element can be converted from the unstable state to the stabilized state. But here they were saying that if you are loose or the oxidation number is going to be increased, so in case of chlorine, we required only one electron, right? We required one electron. Either it should remove or we can drop. So that will give you the completely filled of an orbital. So that point, it doesn't mention an instability or it's a fixed point. So that we can do. But here, what happens? But here, according to their statement, just give me a second. Someone saying we can't join for the class. I inquire it. So what they were saying means instead of adding or removing one electron to balance it out or to stabilize, electrons are present in that same shell. ಒಂದೇ ಶೆಲ್ ಅಲ್ಲಿ ಇರುವಂತಹ ಎಲೆಕ್ಟ್ರಾನ್ ಗಳನ್ನೆಲ್ಲ ರಿಮೂವ್ ಮಾಡಿದ ಮೇಲೆ you can get that stability because of the presence of 3s orbital. So this is a statement given for the D and F. Just I'm giving the example for chlorine. This is not applicable for chlorine. Okay. So now, artha agtidya? Can I repeat? Can you able to understand? So instead of balancing out the unpaired electron, they were saying just remove the electron that present in the outermost orbital, if it is unpaired electrons are present, ನಿಮ್ಮ last outermost orbital ಅಲ್ಲಿ ಏನಾದ್ರೂ unpaired electrons ಇದೆ ಅನ್ನೋದಾದ್ರೆ ಕಂಪ್ಲೀಟ್ ಶೆಲ್ ಅಲ್ಲಿ ಇರುವಂತಹ ಎಲ್ಲಾ ಎಲೆಕ್ಟ್ರಾನ್ ರಿಮೂವ್ ಮಾಡಿ then you can attaining the stability of an element ಅಂತ ಹೇಳ್ತಾರೆ. So yes, Gokul, I'll repeat. Instead of removing, if we adjust one electron, then we bring stabilized for 3p. Yes, that is true. That is in case of chlorine you are saying. Okay. Get it, Meghana? We can do that for chlorine, but we can't do that for D block elements. So for example, I'll give one more thing. Write down the electronic configuration for manganese. For small things we can do, like for hydrogen stability, we can remove one electron, so that will give you the stability. It comes to the sodium. If you have one electron from the sodium, you can do. For copper, if you are removing two, it's done. So, but D series, right? Nice. I'll explain it out. It's 25. Write it for manganese. Oh yes, Aishwarya, but it's not possible to remove all electron in a shell. Yes, we can remove. We can remove. See, just see this manganese. You'll get it now. Okay. So write down the electronic configuration for manganese. It's 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d5. Okay. So just I'll write the last one. D having 5 subshell, right? 1, 2, 3, 4, extra 1, 5. So I'll just arrange. So it's already half filled. According to my statement, what I gave yesterday, half filled electrons are almost stable. Is it right? Halfly filled subshells are almost stable. But then also in D series, if you are come under D series, what happened? Manganese, as I informed you, it can able to lose 7 electrons. But if you are removing one electron, no problem. Nothing will change. Nothing will change. After removing all these 5 electron, again it will drag the electron from the 4s. So then 5 plus 2, it will become totally 7. Then this manganese are going to be stable. To get it? In the D series, Aishwarya, we can't say nothing is possible. Nothing is impossible. We can do whatever we want to do. But we need to try it and naturally without any external forces. So according to the D series, what we need to do, if you are removing 1, nothing will happen. Nothing will happen. But still, if you are removing this 4 2 also, it will become much more stable. Gokul, Nikhil, Srujan. It's a small thing. How can you justify? So justification ಹೇಗೆ ಕೊಡ್ಬೋದು? Okay, how you can say a justification for this means? Gokul, are you there in the class? ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ? ಸ್ವಲ್ಪ ಕನ್ಫ್ಯೂಸ್ ಆಗ್ತೀಯಾ? Gokul? Yes. But we can't remove like this in previous chapter. Yes, that's right. That's why I'm specifying. It's applicable for D and F. Gokul, before starting the lesson, we use one term called DD transition, right? So that is not present in your P block element. PP transition is not there. So only DD transition or FF transition, why it's occur? Because of the more number of subshells. Get it? In S, only you have one subshell. E, you have 3 subshells. That is small subshell. So the middle of the atom can have a control of it. But if you are an F block element, what happens? The subshells are more in number. It directly says that the electrons accommodation also more. If the electron accommodation, it seems to be more, then atom lost the controlling power to the outermost subshell. Outermost subshell alli iruvanತಹ control na kalkollutte. So when it loses, it can lead its own life. Like it's just a life between staying in home, staying in hostel. Okay, like PG. So you can do whatever you want to do in your PG, but home it's restricted. You need to do, you need to eat, everything will be memorized. For hostel, no need to worry. So same like that, you can go at any time, you can come at any time. If you want to eat, you can eat. If you don't want to eat, you can sleep. No one will prize you, right? So same like that, if the atom sizes or the subshells are seems to be less in number, then atom have a control of it. But if it's keep on increasing in number, just think about it. D having 5 subshell, F having 7 subshell, so it can accommodate 14 and it's 10 electron. So the number of electrons are seems to be more, then the force of attraction should be more, but atom cannot increase that. Atom cannot increase that. So that's why it lose the connectivity. So because of that, the electrons are going to be exchanged between themselves. Like this electron will jump from here to here, here to here, here to here, like that. So this is going to call it as DD transition. This is not present in your P. Okay. Gokul, can you able to understand? If you are removing the subshell zone, entire subshell zone, that will gives you the more stability of an atom. That is our statement. Is that okay? Clear? Gokul? Shall I, you need to simplify? Okay, if you got it, fine. Well and good. So next, this is the thing over here. Okay, stability of this is going to be asked you for justification question. Okay, next, chemical reactivity. What do you mean by chemical reactivity? How it will react, chemical reactivity, how it will react. So what do you mean by chemical reactivity? So how this chemical are going to be react with your D and F block series, and what happened with their enthalpy, okay? And what happened with their standard electrode potential, that is E naught of the cell. So if we are mixing the D series with any other chemical, what happened with your structural arrangement, or what happened with the reactivity? So that and all we need to read here. Okay, just a second. Okay, fine. So what happened with your E naught value? So that we need to, this we need to read. It's blur, right? We are reading a first series, that is strontium to zinc, that's 21 to 30. Okay, now just I'm giving the example of krypton. It's in the aqueous condition, so the charge is +2. It will react with 2 hydrogen electrons, that is H plus. We are already reacting with H plus. So what happened? It will give you like this. So for balancing out, S done. So here in this reaction, can you able to say how this can be changing? Like we are donating H plus and H plus doesn't having electron. So we are comparing. So we are just reacting this with your krypton. Krypton already lost 2 of its electron. Okay. So now if you are reacting at 2 cations, so this you need to focus. If we are reacting 2 cations at a time, 2 cationಗಳನ್ನು react ಮಾಡಿದಾಗ, okay, if we are reacting 2 cations at a time, what happen? What we'll get? If any one of the atom which having more electropositivity, it will lose its own electron readily, easily. That's our statement. So ಯಾವುದು more electropositive ಇರುತ್ತೋ ಅದು electron ನ ಬೇಗ ಕಳ್ಕೊಳ್ಳುತ್ತೆ. But ಇಲ್ಲಿ ನಮಗೆ ಎರಡು cationic state ಇದೆ ಅಂದ್ರೆ ಎರಡು already both are already lost its electron. So now we need to think that here if one is donating, one is accepting, yes, that's fine. But here already two of its will lost. Now those two are combined to give some product. So how can we say that based on the electropositivity or based on the size? How can we say? This is our question. Here for that what we can do, this krypton having more electron when you are comparing with hydrogen. Is that right? Hydrogen ge compare madidre krypton hatra electron ide. So but hydrogen doesn't having any electron because hydrogen having one atomic number, it already lost it. So it is only the presence of ionic state, that is H plus. So here we don't have any other option. Krypton should give electron to the hydrogen. Is that right? Haudalvappa? Namatra bere option illa because hydrogen hatra already electron illa. So hydrogen more electropositivity idru kuda it doesn't having electron. Like if you want inner side, you are feeling to give something but you don't have anything to give. So that is the situation of hydrogen. So what happened? Your krypton having some electron. So what it will do, in though hydrogen having more electropotential, krypton is giving the electron for the hydrogen and it will convert the state from +2 to +3 state. It means to say already it loses 2 electron. Again, for the sake of hydrogen, it's again giving one of its electron to become +2 to +3 state. That is called excitation of oxidation state. That is called sorry ನಾನು ತಪ್ಪು ಹೇಳ್ತಾ ಇದ್ದೀನಿ ಅನ್ಸುತ್ತೆ. Just give me a second. Extra. Okay, how can it lose one of its electron extra? For that we need to write the electronic configuration. So write it for 24. Same like that ide tara irutte. So just we'll write 3d4. Okay, because it's 25, right? It's 24. So 1 2 3 4. You can just see here, chromium can able to lose 4 of its electron because it contains 4 unpaired electron. Is that right? 4 unpaired electron ide agirata. So this chromium having the capacity of losing 4 of its electron, but in our state it's losing only 2 of its electron. Because of that reason, when hydrogen ion it comes to attack for the electron, it can readily lose its electron. That's why it can easily convert from the +2 state to +3 state. The maximum capacity is +4 state, and again it can attain +6 also, because here you can see the 4s2 present, so it can remove the s orbital also. Is that right? Clear aita? +2 common oxidation state, +3 and +4 excited orbital state, and it can stretch its oxidation level till +4. Sorry, +6. +6 ವರೆಗೂ ಕೂಡ ಅದು ಸ್ಟ್ರೆಚ್ ಮಾಡಬಹುದು. ಅರ್ಥ ಆಯ್ತಾ ಗೋಕುಲ್? Okay, this is the electrode, standard electrode potential E naught of the M3, like product by reactant. So just tell me that what happened with the electrode potentiality. So it's losing again 1 electron. So electrode potentiality enagbeku, if the potentiality, so okay, I'll tell you one more statement also. The electrode potentiality will depend upon the number of unpaired electrons present, because unpaired electrons galella hogi electrode galige hodidaga it will gain the charges. So So that will gives you the reading. So if the number of unpaired electrons seems to be more, then you can say that the electrode potentiality is more. That is like vice versa. You can say like similarities. What to say? It's directly proportionality. So you can say that. Now we are losing one of its electron. Now tell me what happened with the enthalpy? Unpaired electrons, if you are seeing the unpaired electrons are more in number, you can tell the standardization electrical potential also increase. But here it's having something like, for example, minus 0.83 plus 2 state lidre. So what happen if it is again losing one of its electron? So 2 electron loss agi idagಲೆ ನನ್ನ ಹತ್ರ 0.83 idre, yes Meghana, I'm seeing your answer, but let us wait for the others. So again it loses one of its electron. So now in the plus 2 state we having 2 unpaired electron, and in plus 3 state we having only 1 unpaired electron. So what about the standardized electrode potential? Electrode potential ಏನಾಗುತ್ತೆ ಇವಾಗ? Meghana, actually you're right. Tell me fast. I need to take attendance. Still we have only 2 minutes time. That's it. Tell me fast. Nikhil, Gokul, Srijan, Kiran, Arshita. Arshita, you're not speaking anything today. Mamata, Meenakshi, Mohammed, where were you? Pratap, Ishwant, Sujit, Sujan, Suchitra, Ishwant, Yashaswini, Vishakha, Vandana. Yappa, so many members are there. Tell me. Suchitra, what happened? Electron 2 ಇದ್ದಾಗ -83 ಇತ್ತು ಅಂತ ಅನ್ಕೊಳ್ಳೋಣ. ಸೊ ಮತ್ತೆ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಲಾಸ್ ಆಗಿದೆ. ಸೊ ನಾನು ಏನ್ ಹೇಳಿದ್ದೇನು, ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಜಾಸ್ತಿ ಇದ್ರೆ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ ಪೊಟೆನ್ಶಿಯಲ್ ಕೂಡ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಸೊ ನಾವು ಎಲೆಕ್ಟ್ರಾನ್ ಕಡಿಮೆ ಆಗ್ತಾ ಇದೆ. ಸೊ ವಾಟ್ ಹ್ಯಾಪನ್ ವಿತ್ ದಿ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ ಪೊಟೆನ್ಶಿಯಲ್? ಎಲೆಕ್ಟ್ರಾನ್ ರಿಮೂವ್, ರೈಟ್? ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಎಲೆಕ್ಟ್ರಾನ್ ರಿಮೂವ್ ಆಗಿದೆ. ಸೊ ವಿ ಕ್ಯಾನ್ ಸೇ ಲಾಸ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್. ಸೊ ಟೆಲ್ ಮೀ ವಾಟ್ ಹ್ಯಾಪನ್ ವಿತ್ ಯುವರ್ ಎಲೆಕ್ಟ್ರೋಡ್ ಪೊಟೆನ್ಶಿಯಲ್? ಇಷ್ಟೆಲ್ಲ ಹೇಳಿದೀನಿ, ಇನ್ನ ಗೊತ್ತಾಗ್ತಾ ಇಲ್ವಾ? Fast.